Chapter 14, Energy Methods, Stored Energy Calculation. So if we have a configuration like our figures, here there are two cylindrical solid bars connected to each other with different material, one with a flexural rigidity of EI and the other with flexural rigidity of 2, and a small lies at the free end of yellow part at the top. So we want to calculate the strain energy. We want to calculate the strain energy of this configuration, excluding shearing strain energy. So just having the strain energy due to M naught, and that's a bending strain energy. Because we are excluding the shear, so there's no need to calculate the strain energy due to R. So if you remember the formula, U or strain energy due to a is a 0 to L m squared over 2 EI times dx from 0 to length of our part. If we go farther and just divide the shape to two parts of a first part and second part, first part with EI and length of a 3, and the second part is 2 EI twice of rigidity, flexural rigidity of the first part, and with the shorter length or height of a 1/3 of this part. So the total U, total strain energy to bending, because there's no other force but a at the free end of section 1. So that's a U1 plus U2 strain energy in part 1 plus strain energy in part 2. So if you take out part 1 and just take a distance of x and make a moment about that point, it just gives you summation of moment about x goes 0 minus mx minus m naught goes 0, and that gives us mx is equal to a negative m naught. So u1 is the integration from 0 to 3l, 0 to 3l m squared over 2 pi times dx. And if you replace that, it just gives you a negative m in parentheses squared is positive m naught squared over 2ei from the main formula times the length, which is integration of dx from 0 to a 3l, and that's a 3l. So 1 is a 1.5 m squared l over ei. Let's move for calculation of U2 and add up together to get the total strain energy due to bending moment. So in part 2, we just consider m naught for this part, and the same moment applies at the corner. So the same and the corner, other the same applies at the part 2, which is the interest part of our calculation. So U2 is a integration of 0 to L, this time m again, m squared over 2 times 2 ei, because the 2 is for main formula and 2 ei for rigidity modulus. Extra modulus. So if you the mass, it just gives you 2 is equal a half of this time m naught squared times length over ei. Add these two up finally with each other, it gives you a total strain energy due to bending whole configuration. So in that sense, one can say strain energy due to bending total is just equal to 1. This is U1 plus U2. And if you add them up together, it just gives you total and total strain energy. So total over capital stands for U total and is equal to 1, which is a 1.5 m squared L over EI plus the second part, which we just calculated to be 1/4 of m naught squared times length over EI. And if you add 1 and 2 with each other, it just gives us a total capital, and that's 7 over m squared times length over EI. Thank you.